Welcome back to the FK Engineering YouTube channel for another session. Today we'll discuss how PLC, PAC, and IPC, three main industrial control system types utilized in automation and manufacturing processes, different from one another. Each has unique qualities and uses. We will discuss what these components are as well as how they differ before we begin today's video. If you are new to our channel, consider subscribe and turning on notifications so that you won't miss upcoming PLC, DCS, SCADA or IoT related information. PLC Programmable Logic Controller is where we'll start. PLCs, which are specialized digital computer for controlling manufacturing processes, machinery and other industrial automation applications, continue to be the fundamental building block for many smaller automation projects. PLC is highly reliable and are designed to work in harsh industrial environments including extreme temperature, humidity and vibration. PLCs use ladder logic or other programming languages to control processes and execute tasks based on input and logic conditions. PLCs are well suited for discrete control applications such as on-off sequencing and logic-based decision-making. PLCs are typically used for applications motor control and manufacturing automation. PLCs are also commonly used to control conveyor belts in manufacturing facilities. They can start and stop the conveyor, control its speed, and manage the flow of products along the production line. PLCs can be used to control the filling process in a bottling plant. They monitor the level of liquid in bottles, trigger the filling operation, and stop when the desired level is reached. PLCs can also be found in traffic signal systems. They manage the sequencing of traffic lights to control the flow of vehicles and pedestrians at intersections. Example of PLC: Siemens S7300 and S712. Now let's talk about PAC. Now let's talk about PAC. Programmable Automation Controller. PACs are a more advanced type of industrial controller that combines the features of PLCs and industrial PCs IPCs. They are typically equipped with more processing power, memory, and communication capabilities than traditional PLCs. PACs often support multiple programming languages including ladder logic, structured text, and C, making them more versatile for complex control tasks. They are designed for both discrete and process control applications, making them suitable for a wider range of industries and applications. PACs can be used in applications that require precise control, data logging, and more advanced algorithms. PACs are used in water treatment facilities to monitor and control complex processes, such as chemical dosing, filtration, and disinfection. They provide real-time data processing and control. In advanced manufacturing, PACs can coordinate the activities of multiple machines in a cell, ensuring synchronization and communication between robots, CNC machines, and other equipment. PACs are used in building automation and energy management systems to optimize heating, ventilation, and air-conditioned HVAC system lighting and energy consumption. For example, we have Rockwell Automation Control Logic's PAC. Last but no least, IPC Industrial PC, a rugged computing devices called an industrial personal computer. IPC is utilized for operations including industrial applications or acting as a control system. It makes sure that different processes, whether discrete, continuous, or hybrid, operate securely within predetermined bounds quickly enough and with the appropriate quality. They are more versatile, flexible than PLCs and PACs, but may not be as rugged for harsh industrial environments without proper protection. IPCs can run various operating systems, Windows, Linux, and software applications, making them suitable for tasks like data acquisition, HMI, human-machine interface development, and running complex control algorithms. They are often used in applications where extensive data processing, visualization, and connectivity to enterprise systems are required. IPCs can be a good choice for applications like SCADA, supervisor control and data acquisition systems, advanced robotics, and sophisticated process control. IPCs are commonly used in SCADA systems which monitor and control large-scale industrial processes. They provide a graphical interface for operation to visualize and interface with the entire systems. IPCs with powerful processors and advanced programming capabilities are used to control robotic arms in industries like automotive manufacturing. They can handle complex motion planning and vision systems, data logging and analysis. IPCs are suitable for applications that required extensive data logging and analysis, such as in research laboratories or quality control in pharmaceutical production. CNC machining control and precision machining. IPCs can be used to control computer numerical control CNC machines. They run software to control toolpath speeds and feeds for Precisio Zero in manufacturing. Siemens IPC is one of example of IPC. In summary, the choice between PLC, PAC, and IPC depends on the specific requirements of the automation or control application. PLC are typically used for simple discrete control tasks. PAC offer greater versatility and processing power, while IPC provide the highest level of flexibility and computational capabilities, but may require additional environment protection measures in rugged industrial settings. We will conclude today's video. Show your support by like and subscribe if you don't want to miss our future content related to automation. Until next time, take care and goodbye. For more information, contact us. +92 309 222 1239. Visit us www.fkengineering.com.